notes, you should have the date and you should have all the topics. So if there's something you're struggling with and you can't figure it out from your notes or whatever, you can find it there on YouTube. So it's you can just do a search for the Bearded Math Man. I'm not suggesting at all that you subscribe or anything like that, because it's not that kind of channel. It's pretty boring. It's just math lessons, basically. I mean, there's some stuff on there that's useful and helpful, but it's more of a resource than anything. All right, so a couple of announcements before we begin today. I've got, I know students from last semester, 2 of them have books for sale. So if you're interested in buying a used book, they said $40. So not a bad deal. And so I can get you I can tell you who they are if you want to know. You can just see me after class and I'll help you out there. Let's see here. Off and away. Not even on the desk. Just put away. Turn them off. Put them away. So just put your phone away. Just put it away. It's vying for your attention. It's begging. It's distracting you. It's destroying your brain. It's just sucking the soul right out of your body. Sad story. All right. In all seriousness, if you had something serious going on, like loved one in the hospital or something like that, and you're expecting an emergency, then that's fine. But most of the time, it's like for me, I get all kinds of texts, especially on Thursday night. Especially Thursday night, because there's basketball games on Thursday night. It's my brother texting me about basketball. So, yeah. I won't be answering him either. I'll answer him later. All right. But in all seriousness, we all have a mission here, and that's to learn so you can graduate and all that kind of stuff. So, good deal. Today, what we're going to do, everybody's favorite, fractions. Fractions are your friend. Ernesto, fractions are your friend. You're dressed like a fraction right now. Everybody is. Everybody in here is dressed like a fraction. Absolutely every one of you guys is dressed like a fraction. Yeah. And imitation is the highest form of flattery, Evelyn, by far. Imitation is the highest form of flattery. When you act like somebody else or something else, then that means you're looking up to them, and it's flattering. The reason you're dressed like a fraction is you have something different on the top than on the bottom. We're all fractions. Yep. It's true, Jackie.
No.
Okay, Jackie. So here's some of the things we're going to talk about with fractions, but we'll get into that in just a moment. Before we do, this is our schedule for the day. We are going to talk about questions you have in the homework. I will not be collecting homework. Quite frankly, I mean, look, this class is one you want to take. If you want to take the class and you want to learn from the class, then you have to do the homework, and I'm not going to chase you around. Everybody's going to get full credit for homework whether you do it or not. Doesn't matter. Because if I put a whole bunch of pressure and a bunch of weight on the homework grades, then you just copy. It doesn't matter. My job, one of my jobs, is to give you an appropriate grade, and the grade should reflect how much you know. I don't know how much you know from when you're doing your homework. Even besides that, let's say Jackie's doing her homework and she messes it all up. Right, Jackie?
Right.
Never happens, right? No. Right. I want you to feel free to mess up and make mistakes on your homework, because you're going to learn from those mistakes. And then when you take a quiz, which is when I really know what you know, I know it's not somebody else's work, I know it didn't come from a computer or some program. Since you made all your mistakes on your homework and you learned from it, you're going to have good quiz grades. You'll see. So me chasing you around, that doesn't even work at high school level. Not really. Kids that have to be chased for homework, there's kids that have 100% of their homework and they get 12% on quizzes. And they always say, I'm just not good at tests. I'm like, well, that's because you don't know anything, because you copied your homework. Right. It's true. Ernesto's laughing because he's lived that hell. Is that true? Yeah. We all have, myself included. I have faked homework and BS'd homework and gotten quote-unquote help on homework, where I wasn't copying, but the person helping me was just telling me everything to write. So I might as well have had him. Basically all that happened is he told me what to write and I just wrote it. I didn't learn anything. And test came around, I'm like, man, I suck at tests. I have test anxiety. I just didn't know anything. I was nervous because I knew I didn't know. Yep. Hey, Evelyn. Let's say that. Let's say that you were trying to imagine somebody, and everybody I think can appreciate this. You're trying to lose weight. Right?
Okay.
And let's say you're seeing a doctor to help you lose weight, and they get you on a program. So they say these are the things you're going to eat, this is the exercise you got to do, and every week you go and you check in. First thing you do is weigh you. Right? Can you imagine? Like you got that scenario in your head, right?
Yeah.
Are you going to be nervous when you step on the scale, or are you already going to know if you lost weight or not?
I'm already gonna know.
Right. Same thing happens on a quiz or a test in math. You already know if you're good at it. There's nothing to be nervous about. I mean, I'm going to tell you exactly what's on the test. You're not going to wonder, oh boy, I hope that topic's not on the test. I'll tell you. I'll tell you exactly the topics you need to know. And when you show up for quiz day, you're going to know if you're ready or not. Yep. Okay. So we're going to do our homework review, then we're going to do our lesson for the day, we're going to do some practice, and we are going to G-O-H-O-M-E. Well, you are. I'm not. Okay? So, Marlene, you might not have the question anymore, but you did ask me the question earlier, and I think that's a good place to start. When you asked me, remember?
Yeah.
Yep. Okay, Marlene, let's do it. Marlene's question was about this. Right? Can I write the wrong answer?
No.
Okay. Here's the wrong answer. Yeah. The sign is right. Even though that's a negative, this is the correct sign. But this is, the way you get 10 is 5 plus 5, or 5 times 2. That's how you get 10. But this exponent right here, that means 5 times 5. But it really means negative 5 times negative 5, and that's positive 25. So let me write that more clearly. That really means negative 5 times itself, which is positive 25. Yeah? So we'll have a lesson on exponents next week, I think, actually, where we'll get into this very specifically and it'll be clearer. But exponent of 2 just means the base times itself, so the number there by itself. Yeah? Okay. Who else has questions on homework? Jackie, you got a question?
You do?
I can.
Oh, well, it's the same now and everything.
What is it? Tell us.
Well, the 6 and then the exponent 2.
Do you like this?
Yeah.
Yeah? Okay.
No.
So the only thing, I didn't say this. I didn't mention this. In your notes for the day, like today's 125, right?
Yeah.
You should start off and you should write homework review, because this is actually maybe when you learn the most. This is when we talk about homework. So if you want to do that, that's not a bad idea. Homework review. Now, I need to work on this too. This would not probably be very good notes, because all there are numbers, there's no ideas that are written out. So let's try, I will try to help you. I don't know what you need to write all the time, but I do know that like writing out some ideas is a good idea. So like for example this, the little 2 is an exponent, and it means to multiply the base which is 6 times itself. So that's the idea. Because when you are reviewing your notes, that's what's going to help you understand. Right, Jacobo?
Yeah.
Yeah. That's right, Jacobo. That's what's going to help you understand, is when you write out in your notes like the ideas. Oh, you guys are switching it up, huh?
What? Yeah.
Well, is it because Jackie stole your chair?
No. It's,
I I didn't.
He's got a little haterade going on today. Look at that. Okay. So this is the idea, right? And this is the math. It just means 6 times 6. That's all it means. And 6 times 6 is, of course, 36. So 6 squared equals 36. 36. However you want to say it. Right, Marlene? Yeah. Do you speak Spanish, Marlene? No, okay. That's good, Marlene. What's your question, Marlene?
On the greater than and less than.
Okay.
I got confused with the negatives.
Oh, yeah.
I remember you said about the negatives least or something like
Let's
that.
talk about that. Yeah, let's do that. It's a good idea. So the question is about this versus this and how negatives play, right? So okay, so check this out. If we look at a number line, let's say 0's there, right? Oh, what happened? What happened? Evelyn, are you getting all emo over math?
No.
What happened?
It was already there. I hit myself like that.
So you have a scrape on your arm and then you just scraped it against your notebook? Oh, that probably hurts.
Sucks. I just wanted notes.
You see what math does?
What does math do? Makes you hurt yourself?
Yeah.
Yes.
Oh, okay.
Very
Wow. Evelyn, do I understand this correctly? You hurt yourself sitting in a chair right now?
Yes.
Okay.
And being too excited to write notes, and I did like that.
Okay.
Now I'm bleeding. So.
Huh. All right. Well, so check this out. A little background information, just to make sure we understand this. So on a number line, let's say 0's there, right? And to the right is positive, and to the left is negative. Right? That means bigger numbers are that way, and smaller numbers are this way. Right? Are we good with that, Jackie? Okay. So, Jacobo forgot we're not going to be texting or anything. And stuff,
No, my phone went crazy. It's buzzing. I don't know why.
Oh yeah, it's going to blow up? Because they blow
I
up
don't know
sometimes.
why.
Is it dying?
I
Because
don't know.
mine is dying, and it does that all the time. It restarts.
Let me see. I don't have to turn it off.
Okay. So Marlene, are you good with this? No. So here's the fact, right? Here's the idea. Like, let's say you had. Okay. So first of all, the farther to the right on the number line, the bigger it is, and the farther to the left, the smaller it is. So if you had two numbers like -7 and -8, and you wanted to figure out which symbol could go in between, right? Here's what you do. -7 is somewhere over here, and -8's going to be that way, because they go in order. It's 1, 2, 3, 4, 5. They just keep going in order, and this way they go negative, -1, -2, -3, -4, -5, -6, right? So the farther to the left, the smaller they are. The farther to the right, the bigger they are. This one is more to the right than that one. That means this is bigger. And that's the symbol that would go there. Not yet?
No, yeah.
You sure?
Yeah.
Well, what's so funny? Did you hear a joke?
Nothing.
Do you know what a cow's favorite word in Spanish is?
No. Mug?
Muy.
Oh, really?
Yeah. Cow's favorite word in Spanish.
Why?
Say it. Muy. Moo. All right, never mind. So then, here, let's try this one. I want you guys to try this one. I want you to tell me if this is just true or false, okay? Is that true or false?
False.
False, for sure.
Yes.
Because this is farther to the left than this number. Okay. Now, I'm going to change it. Now, why don't you tell me if it's true or false?
False.
Really? Why? Wait, those bars. What are those bars called?
Absolute value.
That's right.
Distance from zero.
And what do they mean?
The distance from zero.
The distance from zero. Right. Wow. Okay. Sometimes people forget they're in public, maybe. Oh my goodness, it's Mr. Cuevas. No wonder. No wonder. Right, Jackie?
I know.
Oh, yeah. Jackie, how far away from zero is this number?
That much.
10,000, right. So negative 10,000 is 10,000 spaces from zero. So would you agree that that's the same exact number as the absolute value of negative 10,000? Would you agree? Yeah. And then this one, like the same logic, this is going to be 402 away. Is that bigger than that?
Oh,
Yeah, that's true.
yeah.
That's true. Whoa. Absolute value is in some way, like when we're talking about absolute value, we're saying, right here we're saying, which one is farther away from zero? Which is the greatest distance? Is this distance from zero greater than this distance from zero? Yeah. In fact, we should probably write that out. So this part right here is 10,000, negative 10,000, farther from zero than 402. That pen looks like it's dying. That's what it's asking. Okay? Let's see. One more. One more. And we'll see how this goes. You ready, Marlene? This is for all the marbles. I don't know what that means. Well, I do know what it means, but I don't know where it comes from. It means it's for like everything. So, negative 10,000. The absolute value of negative 10,000, is that bigger than the absolute value of 10,000? Is the absolute value of negative 10,000 bigger than, because that means bigger, right? Greater than? The absolute value of negative 10,000, is it greater than the absolute value of positive 10,000? Dun, dun, dun.
Equal.
They're equal, so it's not bigger. Okay. These are the same distance.
Mister,
Yeah.
your focusing thing is
Hate my life.
oh.
I know it's getting all, it's all, I know, I let's see what we can do. Maybe we can fix it. There. Better?
Sí, señor.
All right. Sorry. I didn't see. Thank you. So, check this out. This is saying the distance from zero that negative 10,000 is. It says it's greater than the distance from zero that positive 10,000 is. And that's false, right? Because they're the same distance from zero, so it can't be greater. Good? Yeah? Jacobo, that's easy? Easy peasy lemon squeezy, or is it new for you?
No, I didn't know that at first.
But now you got it?
Yeah.
Yeah, that's fantastic. Wow. Okay. What else will this day hold? And Ernesto, do you have questions on the homework?
Yeah.
Yeah, what is it?
Number 35, which is 4 minus negative 10.
4 minus negative 10, like that? What, the parentheses, like that?
Yeah.
Okay.
Is it negative 6?
Check this out. If it was this, it would be negative 6. If it was this, it would be negative 6. Those are both negative 6. This one's actually 14. You see, those parentheses, they're really not doing anything. They're just kind of getting in the way. These two things are the same. Yeah, that's a good question. You have a question. What's your question?
So, if 0 is 0, does that mean that any number is going to be greater than 0?
Any positive number.
A positive number.
All negative numbers are smaller than 0.
Okay.
Yeah.
So 0 is greater than negative.
Correct. Yeah. Evelyn, are you all healed now?
Yeah.
Yeah? Okay.
I stopped bleeding, so that's cool.
That's a good start to the day. Yeah. Okay. Anybody else got other questions on the homework or anything we talked about last week? Or last class on Tuesday? No, Jackie? Okay.
I have another question.
Yes, ma'am.
When the exponent is a 3,
Hmm.
the 2's are easy.
So,
Or a bigger number.
so let's see here. Ay, ay. Like, for
Let's
example,
do a negative.
oh my gosh, you're getting mean now. Let's do -2 to the third. Like that? Okay. That 3 right there, it tells you how many of these are multiplying together. So that would be -2. I'm really glad you asked this question because there's some sign stuff that's going to come out of this that you guys might get confused on. So that 3 means there's 3 of them all multiplying, right? And they're all multiplying. It's not adding, subtracting. So we can only multiply 2 things at a time. So we're going to multiply these 2 together first. -2 times -2 would be +4. And then we multiply those 2 together and we get -8. Does that make sense? What's that? Yeah? You didn't know that either?
No.
Oh, wow. See, when people ask questions, other people learn stuff. It's weird, huh? Yeah. All right, A squared, what's your question? Do you have a question? Are you distracting Marlene? Because she's going to choke you. Because, look, she's got her phone put away. That means she's here to focus. So if you're talking to her about something not math, she's going to choke you. Marlene looks like she's really nice, but she can be mean. Oh. Okay. So why don't you guys wait. Okay. How many guys didn't really understand this until she asked? Like, show of hands. So we should try one. Let's try one. Oscar, you good at that? Let's try, what about fractions? You good with fractions? Okay, that's what we're going to do today. Jackie's like awesome at fractions. So try this one. You already got it? Yeah. Is it a 3-digit number? Yeah. How much money is 5 quarters?
Wait. $1.25.
$1.25? Yeah. So this would be like same way, right? This, like this and this same, and the only thing different, instead of a 2, it's a 5. Same thing. -5 times -5 times -5. So these two make +25. But we have to multiply that by -5. And that's going to give us a -125. 5 quarters is $1.25.
That was one of the problems for the homework.
Yeah. So we good? Okay. Jacobo, you got another question?
Let me see.
Or maybe not even a question, just maybe a homework problem that you're not sure how you did.
The GCF and LCM for 16 and 42.
Oh my goodness.
Yeah.
Man, we were getting along so good, and then you go and be rude, asking a difficult question. 16, 42, right?
Mm-hmm.
16 and 42. We needed a GCF. Oh my goodness. Jacobo, I thought we were friends. Jacobo, we gotta. Okay. When I look at that, I have to make sure that I understand what GCF means, because I mix them up. If I mix them up, you're probably going to mix them up too. Greatest common factor. Factors are parts. We're looking for the biggest part that these share. And if you remember from last time, when we're talking about parts, we're talking about things that multiply together to make these numbers. So like for example, 2 and 8 are parts of 16. And so would be 1 and 16, and then there's one more pair of parts of 16, and that would be 4 and 4. So those are all the parts.
Yeah.
So if I were to list them, 1, 2, 4, 8, and 16, those are the parts. Like I didn't write them as multiplication right there, but those are all the things that do multiply together to make 16. These are all the factors of 16. So for 42, well, I got to do over here. 1 and 42, that's good. 2 and 21, 3, 14. 4, no. 5, no. 6, does 6 go in?
Yes.
8 times? 7 times. I hate math. 8 doesn't go in, 9 doesn't go in, 10 doesn't go in, 11 doesn't go in, 12 doesn't go in. The next number that goes in is actually, well, we're done. Want to know how? Yeah, no, we're done. You see this right here? You see how it's like they're right side by side?
Yeah.
Yeah, so we're done. Like the next number that actually goes in is 7, and it goes in 6 times, and that's how we're done. And if I forgot that and I kept doing it, eventually I get to 14 and I already have 14 and 3. So here's my list. So 1, 2, 3, 4, 6, 7, 14, 21, and 42. That's my list for, these are all the parts of 42. And I'm looking for the biggest one that's in common. The biggest one they share. Biggest one they share, right, Jackie? Which is...
I put 2.
4. 4. No, there's not 4. Why did I write 4? It's 2. I hate my life.
Wait, it's 2?
It's 2.
No.
Hate my life. You hate my life too? Wow, thanks, Jacobo. Alright, I'll stop picking on you. Yeah. Marlene, I didn't say 4 on purpose. I said it on accident. You want to know why it happened though? Because I'm tired.
Me too.
And I'm not mentioning that I'm tired to make an excuse or to complain. I'm mentioning it because even if you're really good at math, if you're tired, you're going to make more mistakes. So a couple things when you're doing homework or studying, you should do it when you're not tired, if possible. Sometimes you have no choice. And when you are tired, let's say you show up to take a quiz or a test, if you're tired, you have to be extra careful. That's all. All right, Evelyn, you have another question? Maybe even a question that like you think you know how to do it, you just want to see if you got it right? It's the questions and reviewing homework that's really where you're going to learn a lot. If you don't have one, it's fine. I just wanted to, before we started today's stuff, I wanted to see if anybody else had a question.
Well, you kind of gone over everything.
Yeah, kind of. Yep. Okay. Well. Yes, sir?
Can exponents ever be a negative?
It can't.
It can?
Yeah. It can also be a fraction.
Really?
Oh, yeah. Excited about that, huh?
No.
No? Yeah. I don't remember if we get into the negative exponents in this class or not, but I think we do. Yeah. Don't worry, I got your back. I got a game plan for those. I do. I got a game plan for those. In full disclosure, I know how to teach exponents really well. I don't know how to teach fractions very well. I don't have a lot of experience. The only class I have experience in teaching fractions in is this one, Math 81, and I haven't taught it very much. So we're going to do our best. You ready? But it doesn't matter because I can't really teach you math at all. You have to learn it. But I can help you out. All right. Jackie, what's a fraction? And this is chapter 1.3, by the way. I think. Let me double check that for you. Yep, 1.3. It's a fraction. It's a tool of Satan, designed to torture people. Oh, wow. Fractions are Satan's plaything, huh? Fractions.
Fraction are people.
Fractions are people. Wow.
So you said.
Well, no, you're dressed like a fraction.
Oh.
Oh, yeah. Yeah, you're dressed like a fraction. You're not a fraction, you're just dressed like one.
Oh.
Yeah. Daniela, do you know how you're dressed like a fraction? Because you're wearing something different on the top than on the bottom. All right. Here's what fractions are. You know how you have, let's take a look at a number line real quick. Let's say this is 0 and this is 1, and let's say that's 2. There's a whole bunch of numbers in between, and there a lot of the numbers in between, like 1 and 2, and these, by the way, are whole numbers. Like, right? 0, 1, and 2, those are whole numbers, right? In between the whole numbers, there's fractions. Fractions are in between, like 1/2. Fractions describe part of a whole number. That's all. You knew that, right, Jackie? They also go in order. Fractions do. Another way to think of fractions is it's kind of like division too, but yeah, okay. So, I'm going to put two fractions on the board right here, and I want you to tell me which one's bigger. So we got A, which is going to be 1/3, and B, we're going to say, is 1/5. What do you think's bigger, 1/3 or 1/5? 1/3's bigger? Why do you think 1/3's bigger?
Because there are 3 parts to the whole.
Correct.
Versus 5.
So, absolutely right. So by 3 parts to the whole, what this you're saying, I think, tell me if I'm wrong. I think you're saying that this 3 talks about how many parts you cut something up into. And this 5 does too, right? So if you take something and you cut it into 3 parts, each of those parts is bigger than if you were to cut the same thing up into 5 parts. Okay, so 1/3 is definitely more than 1/5. Okay, because you're cutting it into fewer parts, so each part's bigger. Yeah, Jackie? Okay, Jackie. So the denominator, that's the number on the bottom, right? The denominator describes how many parts something is cut into. All right. Thought you said you didn't like fractions. It's the best definition I've heard all day.
I said that?
Yeah, you said that.
How did I say that?
Well, because you said that 3 says that you have something cut into 3 parts. Right. Well, and the 5 means that there's something cut into 5 parts.
Right.
So that means so that denominator tells you how many parts it's cut into.
Yes.
Right. Yes, ma'am.
So 1/3 is bigger than 1/5.
Correct.
Because it's cut into that many parts.
Yeah, like say you have one piece of gum you need to share.
Okay.
Do you want to share that with 3 friends, or do you want to share that with 5 friends?
3.
Right. Because you're antisocial and hate people.
A little bit. Is 5 bigger than 3?
It is bigger than 3, which means it's cut into more parts, which means each part is smaller.
Oh.
Yeah. Say you're going to get a large inheritance from some relative you don't know.
Yeah.
And you're going to kill off some of your family members so you get more money, right?
Sounds good.
Do you want 3 family members left or 5?
3.
3, because you get more money.
And the less people that I know, the better.
There you go. See, even better. Yeah. Okay. So, Evelyn, I'm really glad you made the observation. It is kind of counterintuitive because 5 is a bigger number than 3, but yet 1/3 is more than 1/5. Even though 5 is more than 3. Right. So that is kind of counterintuitive. It is kind of tricky. But this is talking about the number in the bottom is talking about how many pieces something's cut up into. Right. Okay. What about the numerator, the top number? What's the numerator talk about? The numerator. What does it describe? So maybe asking a specific question would maybe be helpful. Which of those two is bigger?
2/3.
Why is that?
It's closer to 3.
Well, that's true.
And let's see. Well, it has the same denominator too.
It does. So first of all, the 3 says something's cut up into 3 parts, right? The 2 or the 1 tells you how many parts you have out of that many. So this says something's been cut up into 3 parts and you get 2 of them. So say you're killing your family members, right? And you're really going to kill all of them except for 2, right? You're going to kill them all except for 2. But one of them begs you, please spare my life. I will not claim the money. So there's actually 3 people left, but you get 2 of the parts. What's that?
I would keep it.
Yeah. So here, let's picture good, word bad, right? That's what Homer Simpson says. Picture good, word bad. So let's say we had our piece of gum. This is thirds. See, it's 1, 2, 3, right? All they're equal. All the parts are supposed to be equal. 1/3 would be this. That's 1/3. 1/3 is shaded. 2/3 are unshaded. Here's 2/3 shaded though. Say a piece of gum. Or a Band-Aid on the floor you found and you want to chew it up, but you want to share it with your friends. So you got to remember, I teach high school. We see weird things sometimes. There. That's 2/3. That's 2 out of the 3, and that's 1/3. Make sense? So let's see. So the numerator describes how many pieces you have. It's a lot to put together. Yes, ma'am.
So which one's bigger?
Between 2/3 and 1/3?
Yeah.
Well, take a look at this. The shaded part is how much you get. And it's something you want. Okay, so let's say it's something you want. Which one do you want? You want this one or you want that one? You want the 1/3 or do you want the 2/3? Which one's more? 2/3 is more. Because the 3 on the bottom says how many pieces it's cut into, and the number on the top tells you how many of the pieces you have. Make sense? Yeah. Now a minute ago, Jacobo said something about 3 out of 3. You know, this is closer to 3, is what you said, right? So let's talk about that real quick. Let's talk about 3 out of 3. 3 out of 3, it's 1. That means it's cut into 3 pieces and you get all 3 pieces. That means you have the whole thing. You have 3 out of 3 pieces. That would look like this. You're going to get to eat the whole Band-Aid. Like you cut it into 3 pieces and you ask your friends if they want a piece and all of them say no. Can't imagine. Oscars, you understand what we got so far? Don't worry about the Band-Aid thing. That's just weird. All right, yeah. But the rest of it, are you okay so far?
Yeah.
Okay. Marlene, you good?
Yeah.
Yeah? Jackie, we good?
Great.
We're great. Wow. Dang, Jackie. Wow. Don't say we're great. That's gonna go to my head, you know. And start getting a big head and going around bragging. I taught Jackie fractions today. All right, Jackie. Ready? So, okay, hold on. I'm going to keep this somewhere. I don't want to lose this because we're going to have to come back to this fact a few times. Because you got it right now, but you're probably going to lose it. Like, you got it, gone, got it, gone. Oh, I understand. Oh, wait, what was that? Okay. Now, I guess we'll start with addition. So, here's the fact. I would love to spend like a whole bunch of time showing you why the fact is true, but the truth is we don't have time because we only have a few months and we have a lot of stuff we got to learn. So we're gonna have to just go with the fact and get a sense for it. Okay, so here's the fact: to add or subtract. Right, that means like or subtract, right? Add slash subtract. We're good. Okay. To add or subtract fractions, the denominators need to be the same. I'm sure you know that. Like you've heard that before. I think everybody's got that. The where you get into trouble, Ernesto, is probably how do you get them to be the same, right? Yolanda, do you know why they have to be the same before you can add them?
Not necessarily.
Not really, right? Yeah. Anybody know why they have to be the same before you can add them? Before you can add fractions together? No?
The numerator can't be greater than the denominator, obviously.
Well, actually, it can, but that just means it's going to be more than a whole. Yeah, it's kind of weird. Okay, let me ask you an easier question that you're really going to hate. Okay, you ready, Jackie? What is adding? What, here I'm going to write down, is adding. It's combining things? How? Like how? Like, what is 3 plus 5? It equals 8. But what happened?
You made it one.
How?
By adding.
How? You can't say adding is adding. That's not a definition. This is really confusing, right? I mean, what is adding? Oh my gosh. What is? Oh, I hate that question. What is? Is. Yeah. Check this out. Adding is repeated count. It's skip counting. Adding is skip counting. Let me show you what I mean. 3 plus 5. Here's what I mean by skip counting. 3 plus 5 means I'm going to count this many, but I'm starting here. So I'm starting here, and I'm going to count 5 more. So if that's 0, 1, 2, 3, I'm starting here. And then I'm going to count 1, so that's 2, 3, 4. I'm going to count 5 more. Starting on 3, I'm going to count 5 more. And so that makes me end up at 8, right? 1, 2, 3, 4, 5, 6, 7, 8. That's what it is. Evelyn, you probably don't understand why that has anything to do with the fractions needing a common denominator yet, right? Oh, I can read minds. Yeah. Pizza. You're all right in my book, Evelyn. You're okay. Check this out. Okay, so we got this idea, right? I'm gonna try to put 3 like seemingly separate ideas together so we can understand this. This is one of the ideas. This is the other idea. Okay, now let's talk about what counting means. When you're counting things that are the same. So, the whole apples and oranges thing. Like, if I'm going to count students, well, 1, 2, 3, 4, 5, 6, 7, 8, 10, right? But if I'm going to count female students, you 2 won't count. You 3 won't count. I didn't see Ernesto over there. He's hiding. Because you guys are different. Right? So when you're counting stuff, you're counting things that are the same. So if we're going to count, well, cars, but not trucks. Trucks won't count, right? They're not the same. So when I'm counting 1/3 and 1/3 and 1/3 and 1/3 and 1/3 and 1/3, how many 1/3s are there? 6 1/3s. Would you agree with that? Would you agree that there are 6 1/3s here right here? Would you agree with that? There are 6 1/3s. Would you agree? Yeah, yeah. Okay. Okay, let's see here. We're gonna try that again. So we have 1/3, 1/3, 1/5, 1/3. How many 1/3s are there? There are 3 1/3s and 1 1/5. You see, they're not the same. You can't count them as the same. When you're adding, you're counting. So when you're counting things that are different, you don't get to say, oh yeah, that's all good. It's like I'm counting money, which I don't really get to do because I'm a teacher. But let's say in my wallet I'm counting money and I got $1, I got $2, and I got a whole bunch of business cards. They're not money. They don't count. If I was just counting things in my wallet, then yeah, I got a whole bunch of nonsense in there, and it's like 47,000 things, but only a couple of dollars. Does that make sense, Jackie? Mm-hmm. If you're counting quarters, for example, 25 cents, which is a quarter, right? That's a quarter. 25 cents, it's a quarter of a dollar. There's $4 and, 4 quarters in a dollar. If you're counting quarters, dimes don't count. Dimes are 1/10 of a dollar, right? And so when you're adding, what you're really doing is you're counting. You're counting things that are the same. You're collecting them and seeing how many are together. So that's why this is true. I hope that makes sense. I don't know if it makes sense or not. That's my best shot right there, Marlene. Do you see why you have to have a common denominator? Because if you don't, they're not the same thing. And if you're adding, you're counting up how many of them you have. Like, for example, would you agree that this is a marker? Would you agree with that? This is a marker, right? And would you agree that those things are, the rest of the things are pens? So if I wanted to count how many pens I had, this one doesn't count, right? I can't count it in the group. Okay. So, luckily, there is a way to be able to count these things together. What you're going to end up doing is you're going to end up, well, let's see if we can come up with one that's kind of easy. Okay, let's see if we can come up with something like, let's say we had 1/2 plus 1/4. Okay, 1/2 plus 1/4. Who hates money? Because I was going to give away some money. You don't want any? Oh, you'd be okay if I gave you money? Yeah. Yeah, you'd just like, okay. So, we're familiar with money. How much is that in money? Half of a dollar. What would that be?
50 cents.
50 cents? How many quarters would it be?
2.
2. How many quarters is that? Right here.
1.
That's 1/4. 1/4 is also called 1/4, right? That's 2 quarters. That's 1/4. How much is 50 cents plus 25 cents? 75 cents. And 75 cents is how much of a dollar? Would you agree it's 3/4? That's true. This is 3/4. And the reason, whoa, that was a good sneeze. That was a good sneeze. Ernesto, are you good? 2 quarters? That's 2 quarters, half of a dollar. This would be 2 quarters. That's supposed to be a U right there. And this is 1/4. You would agree those are 3/4, right? Okay. We can change halves into quarters. That's what we're going to do. So in order to add fractions together that they don't have the same denominator, we have to make the denominators the same. And we can change them to be the same number. So here's the fact. We can change them. The denominators to be the same number. Then you can add them. Yeah. Jackie, two things we need to get in our heads right now. Okay. The first one, Jackie, is how do we figure out what number to change them to? So two things. So two issues. Issue number 1. How do we figure out how to determine what number they should be? You know what I mean by they, I mean the denominators, right? So our first issue is how do we figure out what number they're going to be? And our second issue, Penny, we doing good? We doing good? Do you already know how to do this? You think so? I hope so. I hope so. I hope you learned something anyway. I think you learned what adding was. You didn't know what adding was, I bet. You were taught how to add since how old? Like 4? And you never knew what it was. That's funny. Yeah. Huh. Okay. I bet you could ask most math teachers what adding is. And I'm not saying I'm better than most math teachers. I'm just saying that I've challenged myself to make sense of it, to try to help you guys. But I bet you could ask most math teachers what adding was or is, and they'd be like, have a hard time to say it. I bet. I'm gonna do that. I'm at lunch tomorrow. I'm gonna ask the other math teachers what's adding. You'll have to remind me to tell you how it goes, okay, Jackie? I bet they're not going to be able to say it very easy. But after a while they can, but not right away. Okay, so Jackie, our second issue is after we figure out what number the denominators need to be, we got to figure out how do we change them. Without, and this is the big thing right here, without changing the value. Because what we really mean here, what we really mean by change is we really mean like you know how you could have a $20 bill? Well, that would be the same as a 10 and a 5 and 1, 2, 3, 4, 5 $1 bills. Do you know what I'm saying? It's going to look totally different, but it's the same value. Make sense, Marlene? Yeah. Do you like having a lot of $1 bills, or would you rather have just like one $20 bill? 120. It's easier. Doesn't look as cool though. Yeah, I'd rather have 21s and a 20 wrapped around the outside of it. It looks like you're like rich, right? Yeah. Okay. So, anybody know how to do this? How do we figure out what number they need to be, the denominators, when they're different? Anybody? Anybody know? You're right. It's going to be the lowest common multiple, which you guys are all experts at because we did that last time. Marlene's like, yes, I was hoping we were going to do more LCM. Yes, it's like Christmas in January. Yep. You're going to find the lowest common multiple. And if you're not very good at that, that's okay. We'll work on it. We'll just practice it. It's okay. And then This one is with multiplication. Okay? So the method we use to change fractions so they have the same denominator is with multiplication. Listo, Evelyn? Okay, let's see how this goes. Ready?
Yeah.
Captain Caveman, here we go. We're going to add some fractions together. You ready? All right. Let's say we had 7/10, and we wanted to add, oh boy, let's say we wanted to add 3/5. Before we get into that, do you know how to tell if a fraction is more than a half or less than a half? A half means that something's cut into two parts and you have one of the two, right? Do you know what I'm saying? Like a half would mean that you have something cut into two parts and you have one. So imagine something's cut into 10 parts and you have 7. Do you have more than half?
Yes.
Yeah, because 5 would be half, right? So this is more than a half. Now, this one's a little trickier. What's half of 5? If you had $5 and you spent half of it, how much you got left? $2.50. 2.5, 2.5. 3 is more than that, right? These are both more than a half. Yeah? Yeah, Jackie, or no Jackie?
Yeah.
Jackie, if you had a half and you add them together, do you get a whole? So if you have more than a half plus more than a half, do you have more than one? That's right. This is going to be more than one. Which is, like you were saying earlier, the numerator is going to be bigger than the denominator. Oh yeah, it's going to be fancy. It's going to be fancy. Yeah. Okay, so let's do it. What is the LCM of 10 and 5? That's the GCF. LCM's the other way. What's the smallest number they both go into? So in case you forgot, for LCM, here's how I would do it. I would start with the bigger number and first see, does the smaller one go into it? That's it right there. It's 10. 10 is the LCM. The smallest thing that 10 goes into and that 5 goes into is 10. They both go into 10. Which means we don't have to change this one. It's going to stay the same. But we do have to change this one. How do we make a 5 into a 10? With multiplication? By 2, right? So what I'm going to do is I'm going to multiply by 2. The reason you have to multiply by 2 over 2 is because, what's that equal? What is 2 out of 2 equal? 1. Right. Equals 1. And when you multiply by 1, Ernesto, what's 5,206 times 1?
1,206.
Oh, it's the same. Okay. Jackie, what's your face times 1?
I heard you say that.
Why was that rude? Oh, what is your face, right? Anything times 1 is itself. When you multiply by 1, nothing changes. That's the point, right? So this really equals 1. It doesn't look like 1, but it equals 1. When you multiply by 1, nothing changes. It's just going to look different, like the difference between a $20 bill and 2 tens or something. So that's going to be 7 out of 10. Now, in case you don't know how you multiply fractions, you just multiply the top numbers together, which makes 6, and you multiply the bottom numbers together. That makes 10. You see? Evelyn, we good?
Yeah.
We're Gucci?
Yeah.
All right. Ernesto, check this out. When you're adding fractions, okay, think about this. When you're adding fractions, you're just counting them. You're just counting how many there are. And we're counting tenths. We are counting tenths here. There are 7 of them there, and there are 6 of them there. 7 plus 7. God, I gotta take my shoes off. God, so 13, right? 13? 13 tenths. Because the tenths are what we're counting. That doesn't change. The tenths stays the same. Right. You good?
Yeah.
So pizzas are cut into 10 equal parts. Okay? Pizzas are cut into 10 equal parts. You eat 13 pieces of pizza. Because Pizza, good. How many pizzas did you eat? Did you eat a whole pizza? If there's 10 pieces in one pizza, and you ate 13, you ate more than one, right? This is actually 1 3/10. Now, Oscar, if you want to leave an answer like this, unless it says not to, you can.
How would it say not to?
Like if it says write your answer. Good question. This is called an improper fraction because the top is bigger than the bottom. This is called a mixed number. So if the instructions said to write your answer as a mixed number, you'd have to do it like that. That's a good question. Hey, Jackie, in England, they don't call them improper fractions. They call them vulgar. Really? They call them vulgar fractions.
For real?
For real. Vulgar just means like common, like trashy, like anybody can write. Vulgar. And so vulgar language means that's what low class people say. Yeah. I guess I'm low class. All right, Ernesto, you see how that goes? Should we try one?
Yeah.
Yeah? Do we want to do subtraction or you want to do addition? You get to pick. What's that? No, the sky's the limit, buddy. I mean, I'm here for you.
Alright, do subtraction.
Oh boy, living dangerously. Okay. Well, here, let's just do this. Let's do. Do you want? Okay. Let's do 2/3 minus 1/4. Let's try that. 2/3 minus 1/4. All About You, Girl. That's a song from SpongeBob. Do you know that?
No.
No? Oh yeah,
I
it's
don't
true.
watch SpongeBob.
You don't watch SpongeBob? Oh wow. Okay. It's true. It's a song with SpongeBob. It's All About You, Girl. Ernesto knows that song, I'm guessing. You don't know that song? Really? Jacobo, you watch SpongeBob?
Yeah.
You ever see the episode where he sings a song, It's All About You, Girl?
Oh yeah, I know it.
See? Yeah. Yeah.
Really?
Yeah.
The one about the boy band and that thing?
Uh-huh.
Yeah.
See?
I've seen all of them.
Yeah. So we're going to do this one right here. We're going to do that one right there. When you got it, check with somebody. Don't take forever to write it down. Try it. Don't avoid it. Try it. You're going to find, remember, you're going to find the lowest common multiple of 3 and 4. And then you're going to change it. It's a little more than a hint, I guess, huh? You good? You got it? Dang. Who needs more time? Okay. Jackie, who did you check with?
I'm not done.
Oh! You have to multiply both of these, right? Because you can't change 3 into 4 or 4 into 3. So you have to multiply both of the fractions by something. Here, I'll give you another clue if you're stuck. I'm not going to do the whole thing, but I'm just going to set up what to do in case you don't know what to do. You know, these need to be 12. That's the smallest thing they both go into. So in case you can, the way you change 4 into 12 is by multiplying by 3, right?
Yeah.
So you're going to multiply by 3 over 3. And the way to change 3 into 12 is to multiply by 4. So you're going to multiply by 4 over 4. Yeah, Marlene or no Marlene? Come on, Vamanos, everybody, let's go. Come on, let's get to it. You know that you can do it. You got it?
Yeah.
Yeah. Ernest, did you get that? Yeah. That's what I got. I got 5 out of 12. 5/12. 5 out of 12. So like on a test or a quiz, this would be a bad grade because 5 out of 12 is less than half. Half is 50%, right? But the reason I mention that is because when we're talking about like a test, that would mean there's 12 questions, and this would mean you got 5 right. 12 questions for the entire test. So the test is cut up into 12 questions, and you got 5. That's kind of what a fraction means again. How are we doing? Thumbs up, I can add and subtract. Sideways, maybe. Kill me now. So what do you got? Let's see. Let's see. Yeah? Okay, so we're doing okay. We're doing okay. Okay. Let's try a trickier one then. Just, you know.
Yes, sir.
Yes, yes ma'am.
Like, what is the answer when
These
I
fractions.
say 2/4? Can you like?
Reduce?
Yeah.
Yes. I haven't taught you how to reduce yet, but yes, you can.
Oh, okay.
Yeah. And you should. Like we will eventually. Yeah. Marlene, I'm very willing to go really slow with this fraction stuff at the beginning, thinking that it's going to help you out later, the things that are more difficult. So, yeah, I want to make sure we got this. Okay, Jackie, you ready?
Yeah.
All right, Jackie. Let's do this one right here, Jackie. Let's do 1/6 plus 5/8. And yes, it's a tricky one, I promise. It's tricky because the number is tricky. Did you get it? Yeah? No problem. What's your denominator?
Wait, yes, yes.
Usually people say 48.
Yeah, that's what I was like, oh wait.
24. That's the smallest thing they both go into.
Right.
24. That's the LCM, right?
Yeah.
Yeah. So 4 over 4. Is that right? And 3 over 3.
Wait.
The smallest thing that 6 and
Okay,
8 goes
yeah.
into is 24.
Yeah.
So 4. So that's going to give us 4, right?
Mm-hmm.
And that's going to give us 15. So I'm not going to show the work, but 4 plus 15 is 19. Okay?
Yeah.
All right. 19. Yeah? Okay. You good, Marlene?
No.
No, why?
Confusing.
You want to try another one?
Would it make you happy?
Yeah.
Then let's do it. Sky's the limit for you, Jacobo. Whatever you want, buddy. Let's do this. Okay. Subtraction?
Yeah.
Different numbers?
Yeah.
Okay. Let's do. Let's do. Oh, I know. Let's do 5/12 minus. Or 1/9. 5/12 minus 1/9. 12 and 9 is kind of tricky. Jackie, you're creeping me out. Jackie, come on, Jackie. Focus, Jackie. Come on, Jackie. Don't be like that, Jackie. Why you gotta be like that, Jackie?
What?
Why you gotta be like that, Jackie?
I was actually using my calculator.
Lie your face.
I was?
Lie your face, lie your
I was.
face, lie your face, lie your
I
face.
swear on my life.
Lie your face, lie your face, lie your face, lie your face.
Because I don't know how you got 19.
Because mira, chica. 4 times 1 is 4, right? So that's going to be 4 over 24. Right? 3 times 5, 15. 15 plus 4, 19. Good thing I like you, Jackie. Does Evelyn have this one? Not yet? Okay. Does Marlene have this one?
I got it.
You got this one? Yeah. Marlene, are you stuck on finding the LCM of 12 and 9? What's that? Well, wait, that's what you do first, is you figure out what's the smallest thing that 12 and 9 both go into. That's what you start with every time. Yes, ma'am.
In these, like, in the fractions in this book, it's like the negative and positive.
Oh, yeah, all that's the same. Yep. So, Marlene, that's what you have to start with, is what does 12 and 9, what's the smallest thing they both go into? So, what you should do is you start with the bigger number, 12. Okay? So, let's write all the numbers that 12 go into. So, we got 12, 24, 36, 48. I'm going to stop. Because what we need to do every single time is we need to see, does 9 go into this number? So does 9 go into 12? Does 9 go into 24? 9 does go into 36 times 4. Right? So you're going to multiply this by 4 over 4. And then you got to figure out, well, how does 12 become 36? And that's times 3. So we're going to multiply this one by tree over tree. Yeah? Marlene, that help? If you can figure out how to start, then you can figure out the rest.
Wait, how'd you get the 3?
Math and magic. Because
I get how you times it by the 4, but what about that 3?
because 12 times 3 is 36.
Oh.
Because that's going to make these both 36. So that's going to be 4, and that's going to be 15, and that makes 11. Oscar, you doing better? Feeling confident? Good. You ready to get your soul crushed? Teasing. 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 Okay, so we're doing all right, right?
We're doing well.
Would it make you happy, Marlene?
Yeah.
Come on, Vamonos, everybody, let's go. Come on, let's get to it. You know you can do it. Yep. You know where we're going? Froggy Waters. That was my favorite episode of Dora. Yeah, it was. But in that episode, Diego was just being a little bitch. It's true. I mean, God, that kid. Can't stand him. All right. So let's see here. Let's do 5 out of 8 again. Let's use 8 again. And let's do plus, 1 out of 10. Oh, yeah. It's a good one. You never thought of Diego like that, but it's true. You watch Dora the Explorer, and Diego's just whining all the time. What'd you get for the denominator, Jacobo?
40.
Right? And your sister doesn't believe you?
Yeah, she did.
She didn't believe. She think it's 80? Does she think it's 80?
Yeah.
Oh no, it's a trap. Watch out, it's not 80. Yolanda, are you feeling more confident with these than before?
Yes.
Yes, good. Is that what you got? 29? Yeah. Ernesto, how you doing with this?
Pretty good.
Pretty good? Were you good at it before?
No.
No? So we're doing fantastic. Well, that's fantastic.
Like, I'm understanding it,
Okay.
but I still have some doubts.
Sure. That just takes experience, because that's what makes confidence is experience and success. Yes, sir, Jacobo.
Yes, sir. This class starts at 5:15 or 5?
5.
Because I started at 5:15.
No, 5. Yeah, I said 5.
Sorry, Mr. I didn't forget.
Okay. I was wondering, like,
Yeah.
because you guys were late, but you were late the same exact time every time.
Yeah,
I'm
no,
like,
that's like-
weird. That's weird. I'm like,
Yeah,
yeah.
class started.
And you're like, what's going on? We missed stuff.
Yeah.
Yeah, 5. That's funny.
Sorry, Mr.
That's okay. Your sister was wondering, she didn't want to ask me, huh?
Yeah.
Yeah. Yeah. All right. Okay. Let's see here. We've got a lot to do still with fractions, but we don't have a whole lot of time. And I'd like to do 10 solid more minutes. So I think we can 10 minutes. I think we can do 2 things. I think we can do multiplication and division, because those are easier than this. This is harder. Multiplication and division, you probably already know how to multiply because it's right there. Right? You just multiply the tops together and you're done. Tops and bottom. Right? So, like, for example, by the way, did you know, Ernesto, that cows can multiply? Like, they're born, they can do like multiplication. They can do math. They can multiply. But they can't add, subtract, or divide. To add, subtract, or divide, they have to use a calculator. All right.
Have you heard all of these before, Jackie?
Oh yeah. Oh yeah. Jackie, imagine living with me when I would say that. I say those things all the time. Can you imagine? Can you imagine? Can you imagine? Oh yeah. Okay, Jackie, you ready? So to multiply, you just multiply the tops together and you multiply the bottoms together, and that's it. Okay. Now, reducing, which I guess we're going to save reducing for next Tuesday. Reducing does kind of change it a little bit, but we're not going to worry about that yet. Okay. So to multiply, like let's say we had 5 over 11 times 3 over 8. Right? It's different than adding. The denominators do not matter, because multiplication combines things different than counting, than adding. Multiplication does it differently. So this would be 15 over 88. 88. 15 over 88. Because 3 times 5 is 15, and 8 and 11 makes 88.
So you just multiply right across?
Right across.
Yeah.
The numerators multiplied together, and the denominators multiplied together. That's it. Just like when you get a common denominator, that's multiplication of fractions. Okay?
Because I used to think it was the same steps as the...
Is the adding? Yeah, no, it's not. The denominators don't even matter. Yep, you just multiply them together. Good to go?
Yeah.
That's easy, right? Like, that's easy. Just straight across. So multiplication. Straight across. So we'll put some arrows on there in case you forget. Right? It's all multiplying. What about division? Oh boy, division is where we get into a little bit of trouble. Division is multiplication of the reciprocal. Dang. I'm going to write that down. Division I hate writing by hand, because if I misspell something, there's not like a little red squiggly line underneath, and then I always second guess myself. But that's how you spell reciprocal, I think. And what reciprocal means is flipped over. When you multiply by the reciprocal, what you're doing is you're flipping something over. So, Marlene, you're probably tired of learning, tired of fractions. We're almost done. There's like one really, really important thing. Okay? And that is this. When you're multiplying both numbers together. You could say like this. You could say 5 times 3. That is absolutely the same as 3 times 5. They're both multiplying together. But division's different. Because with division, you can't change them. They're not the same. Like this is more than 1. That's less than 1. Right? What you're actually dividing by is you're dividing by 3. This is 5 divided by 3. That's what that is. That's 5 divided by 3. Yeah? No, or, another way you could write it, 5 divided by 3. It looks like a fraction that way, right? Okay, so you're dividing by the second number. That's the key, right? Dividing by the second number. And what division is it's really multiplication of the reciprocal, and the reciprocal means you flip it. So that's why for this one, now let's go to this one, it'll be simpler. This is what we're dividing by right there, right? So what this is really going to be, you see, the reciprocal means it's turned around. To reciprocate means to give back. To return a favor is to reciprocate.
How do you know which one to reciprocate?
What's that?
How do you know which one to reciprocate?
To flip over, how do you know? Because it's the second one. The second one's the one you're dividing by. So the first one stays the same. You're dividing by the second one. That one is the one that gets flipped over. And then it's just multiplication, so you can just multiply. Increíble.
Yeah.
Oh yeah. Evelyn, you look like you have a question.
So all we have to do is just look at like the second numbers?
Second number.
Yeah, the second numbers and then just flip them over and
That's it.
multiply them?
That's it.
That's it?
That's it. Oh yeah. I've heard of holy water. I've never heard of holy crap. Like, I can't imagine a church that has holy crap. Bless you, my daughter. Right? I just no. But you know how they make holy water? They take regular water and they boil the hell out of it. Sorry. Sorry, forgive me. Sorry, Oscar. You want to know the real reason I tell jokes that are really dumb like that is because it really makes me laugh when people don't get them right away. And sometimes I don't get them right away. And then the reaction when you don't get it right away is so funny. That's what's funny. When people laugh at them like when they don't get it right away. Okay, Jackie. Quit texting me, Jackie. I'm old and married, and it's creepy. And you're letting Yolanda down.
I'm sorry.
She's here. She wants to learn. Jackie.
I'm sorry, is my sister?
Your sister.
That the baby fell again.
The baby fell again.
Yeah. He fell again.
Babies fall all the time. They're really flexible and bouncy. It's okay.
I want to know what type of again. Because last time he fell off the bed.
Uh-huh.
And that was a really high bed.
Uh-huh.
So we had to go to Susan.
Uh-huh.
So.
Okay.
She's very clumsy.
Uh-huh. Babies are clumsy because their heads are freakishly large.
Oh, yeah.
Yeah, they're top heavy. They fall over.
That was a big hair.
Yeah, it happens. It happens. They heal though. Babies heal. Okay, let's try one. You ready, Jackie? Let's try one. Let's do this one right here. Let's do two. Let's do two of them. Let's do 1/2 divided by 1/3. And then, oh boy. Man, I haven't taught you how to do whole numbers and fractions yet, so I guess that wouldn't be fair. So let's end on a good note. Let's end with no confusion. Let's do one. Let's do 5/8 divided by 4/3. Let's do those two. And then I'll give you your homework assignment and we'll be done. Got both of these, Marlene? Yeah. Not so bad, is it? Yeah, especially when you just like, you're just like devoted to it. And you're like, I'm gonna do this. No big deal. You know how old people all over the entire planet are when they're taught how to do fractions? 10. 9 and 10 years old. Have you ever been around a 9-year-old? They're idiots. All of them, even the smart ones. 9-year-old and 10-year-olds are crazy, especially the boys. They just want to set everything on fire. That's what 10-year-old boys do. But 9 and 10-year-olds are smart enough to learn this. And I don't say that to make you feel bad if you don't know it. That's not my point. If you don't know it, you just never learned it when you were that age because you never had anybody that made you learn it. Because it's uncomfortable to learn. Learning is a very uncomfortable thing because we feel insecure when we feel dumb. It makes us feel bad. So a lot of times we avoid things. So if you never learned this when you were a kid, it's just because nobody made you. Well, now you have to make yourself because you're an adult, and that's harder to do than if somebody's making you. You know? So anyway, let's start with who should we call on, Jacobo, for the first one? Let me ask you this:
Yeah.
Who would you trust would get it right? Like, say there was a 1-question test, and everybody tried it, and at the end I got to say you can pick one person, and if that person has it right, you get 100. Who would it be?
Do I have to pick someone for this?
Uh-huh.
Diana.
You wouldn't pick me? Okay, great. I'm just teasing. What do you got, Daniela? What'd you get for the first one?
What? What's it again? Oh, this one.
3 over 2? 3 over 2. Yeah, that's fine. 3 halves, 3 over 2. Yeah, that's it. We good? Yes? Okay. Daniela, you could pick anybody except for your brother. And you want to know a right answer. Who is it going to be? Who do you trust? I know you don't know anybody very well, right? Oh boy. So who would it be? You don't know? Oh. Oscar. His name's Oscar. Hi, Oscar. Oscar.
15 over 32.
He said 15 over 32, and he's right. That's right. I didn't show the work. Those are just the answers. So we good? Yeah? Okay. Hey, one last thing before I give you your homework assignment, and it's not a math lesson. It's just some perspective about math. I've had a handful of teachers that were really influential, and one of them, what he said, was really interesting to me because I'm taking math classes at the university, and they're hard math classes, and the people teaching them, they all have PhDs in math. So I'm thinking these guys are like geniuses. So the guy was saying, he was young too, he was saying, look, I'm not a genius. I had to work really, really hard. And he said what he did when he was going to college is when he took a math class, and this is super nerdy, but it's devoted, he did every single problem in the entire book. Because the way he said it is every time I do a problem, I'm going to learn something. And if this is what I want to know, then I don't want to leave anything to chance. I don't want at the end to say I could have done better. I want to do my best. So anyway, that in combination with the second idea. Ernesto, it's hard for me to assign homework because I don't know how much practice you need. Too little practice is really bad because you need more practice. And I don't know how much you need. Too much practice is just busy work. And that's no fun either. The purpose of homework is to learn. So here's what I'd suggest. I would suggest doing a little bit of this every day. 5 problems a day maybe. So that's Friday, Saturday, Sunday, Monday. So that's 20 problems. 5 problems a day of add, subtract, multiply, and divide fractions. Probably will take you 5-10 minutes a day. That's it. But if you do it every day, then it doesn't get old in your brain and disappear. It stays fresh. So you just say, okay, I'm going to get up in the morning, I'm going to brush my teeth, I'm going to tell my kids to go to hell for 10 minutes. And then I'm going to do my math, and then I'll take care of whatever I need to take care of for the day. Okay, so you guys set a time, and it'll help. So in the book, here's what we got. We got page 43. Okay? And we know how to do, okay, I'm not going to write down what I'm assigning. I'm just going to say, these are the problems we know how to do right now. We know how to do everything from number 57 through 63. And then we know how to do everything from 65 through 68. These are not the assignments. I'm just saying these are the problems that you could practice. And then we know how to do everything from 71 through 88. We know how to do all those. Like you should be really solid with all those. And if you get confused, I'm hoping you take good notes, because your best resource is your notes. So I would say, let's see, how many is that's quite a few. I would say if you did 20 problems over the next 4 days, I'd say when you showed up on Monday or on Tuesday, you're rock solid, you're ready to go, and you're not going to have trouble. That's what I'd suggest. So I would suggest just picking 20, just 5 a day, which maybe would take 10 minutes, probably not even that. It would probably take you longer to get your book out or your homework or whatever. Okay? Now, Jacobo, there's some people that have a used book from last semester, and they're going to sell them. So if anybody wants to buy a used book for $40, is what she said. There's actually 2 of them. Okay? Sonia and Sam. But I forgot her last name. Oh. And they gave me their number, and I left it here underneath the keyboard, and somebody cleaned. Jackie can get you in touch with them, I guess. Yeah. Okay. So, ladies and gentlemen, we did fantastic today. Well, you guys did fantastic. Hope you have a good weekend. That's all we got.